Welcome to Lesson 2, Build Models from Data. Our objectives in this lesson are to be able to identify the revenue, cost, and profit equation given various equations, to then identify the key components of each of these equations, as well as to build each of these equations given a series of data. Let's think about the characteristics of key business equations, and we can do that by answering this question. What is your revenue, cost, profit when 0 units are sold or produced? In other words, at the starting point, before we've sold anything or before we've produced anything, what is our revenue? What are our costs? What would our profit be? Well, let's look at revenue first. If we have not sold anything, we will not be bringing any money in. Therefore, we'll have $0 of revenue. Thinking back to a previous lesson, our revenue equation can be modeled by the price that we charge per unit, let's just say it's $5, times the number of units sold. If we sell 0 units, so X is 0, then our revenue is 0. So this makes sense. Now let's think about our costs. If we don't produce anything, what are our costs? Do we even have costs? Well, remember back, costs can be broken into 2 categories, both fixed and variable costs. Now our variable costs are only incurred when we produce units, because those depend upon the number of units we produced. If you remember, if we painted jeans, then each pair of jeans we painted, we'd have to buy a pair of jeans. That was one of our variable costs. Whereas our fixed costs incur whether we sell or produce any products. So we would have some costs. We would have fixed costs. So whatever those are, whatever that dollar amount, we would have those costs. So if we think about our cost equation, we would have 0 variable costs, but let's just go ahead and call that V of X, plus our fixed costs. So if we do not produce a single unit, we will still incur these fixed costs. Now let's think about our profit. Our profit is our revenues less our costs. Well, if we're not selling and we're not producing, we know that our revenues are 0, but we have fixed costs. So our profit is going to be negative. We are going to end up with a negative profit. And if we think about our profit equation, the profit equation is really just our sales price per unit less our variable cost per unit minus our fixed costs. So if we sketch this out, we could say that our profit equation is really just our revenues minus our variable costs per unit, and then we have to subtract of our fixed costs. And that way we would have a negative profit if we sold and produced 0 units. Knowing this information, we can identify the different types of equations. On our next slide, we are going to look at some data. We're going to build equations from this data. They're going to be linear equations, and we're going to use the information we learned from the previous slide to identify which of these equations is which. Let's go ahead and start with our first t-table here. If you remember, if these are linear, they're all going to be in the form of y equals mx plus b. And if you remember that m is the slope and b is the starting point, the y-intercept. Notice that on all of these tables, we do have a starting point where x is 0. That means that this represents 0 units sold and produced. So these are our starting points. You may be able to just look at this and identify which equation each of these tables of data represents. But let's go ahead and build an equation. If you'd like to pause the tape and make a prediction first, go ahead and then we'll see if you're correct. Okay, let's build the first equation. So let's find our slope. We need to pick any 2 points. So I'm going to pick this first point, 0, 0, and the second point. Let's try that again. 0, 0, and then I'll pick the second point. That'll be easiest. Those are the smallest numbers. So between these 2 points, I'm going to find my slope. I have 0, 0, and 2, 50. Remember that slope is just change of y over change of x. This is my x, this is my y, this is my x, and this is my y. So I'm going to have 50 minus 0 over 2 minus 0. 50 minus 0 is just 50, and 2 minus 0 is just 2. 50 divided by 2 is 25. My slope is 25, and my starting point is 0. If I did not have this initial starting point, I would need to pick a point and plug it in. If I had to do that, I would write my equation, y equals 25x plus b. Remember, we just found m, so we can plug in the 25. And then what I would do is pick a point from the table. Let's just pick 4 and 100 and plug those in. I would put 100 in here for y, and I would put 4 in for x, and then I could solve for b. 25 times 4 is 100, and if I subtract 100 from each side, I get 0. But then again, I knew that my starting point was 0 because it says it right here. So my equation for this problem is y equals 25x plus 0, or just y equals 25x. Let's go ahead and look at the second equation over here. Same thing. Let's find our slope. So let's pick a couple points. Why don't we pick the first and the second point again for simplicity's sake? Okay, our slope is going to be change of y. So I have a negative 180 minus a negative 80 all over 0 minus 10. It doesn't matter which order we subtract these as long as we are consistent. So if we started with 180 and we subtracted the 80, then we need to start with 0 and subtract the 10. Okay. Negative 180, and I change these both to pluses because a double negative becomes plus. So negative 180 plus 80 is negative 100, and then 0 minus 10 is negative 10. Negative 100 divided by negative 10 is positive 10. That's my slope. And I know my starting point because I have where x is 0 here. So the equation is going to be y equals 10x minus 180. Let's go ahead and look at the third example. In this example, once again, we have our starting point. So we know what our y-intercept or b value will be, but we don't know the slope. Let's go ahead and find the slope. Again, I'm going to choose these top 2 points, but you could choose any 2 points in your table of data. And this time I'm going to do 225 minus 180, so that's my change in y, divided by my change in x, so I'm going to have to start with the 3 minus 0 on that one. 225 minus 180 is 45, and 3 minus 0 is 3, which gives me a slope of 15. If we write our equation, we end up with y equals 15x plus 180. I have now built 3 equations using algebra, so now it's going to be important to identify what these equations represent. Let's look at these for a minute. This first equation does not have a y-intercept. That means that this is our revenue equation, because when we sell or produce 0 units, we will bring in $0. So we can identify this first equation as our revenue equation. How about the second and the third equations? Well, in this first equation, if we sell 0 units, so we plug in a 0 here for x, y would equal negative 180. What type of equation do we end up with a negative value? That's our profit equation. If our profit equation has a negative value, then what about our cost equation? Well, that means that we have costs. Our cost should be this 180, which is our fixed costs. So if we produce 0 units on this third equation, we still incur costs of 180. So that's positive to us. But remember that profit is just revenue minus costs, and that's why it's negative. So our last table of data represents our costs. And there you have it, revenue, profit, and costs. Finally, let's conclude by identifying some key points. What if I said, what is our sales price per unit? Well, hopefully you would identify that as $25 right here. And that's because our sales that we charge people are $25 per X, which is per unit. What if I said, what is our cost per unit? Well, you would look here at our profit equation and our cost equation and try to figure that out. Well, our profit equation doesn't tell us our cost per unit. That tells us our profit per unit. So let's move over here to the cost equation. This 15 tells us our variable cost per unit. So it's $15. Now what if I said, what is our profit per unit? Well, then we know it has to be $10. Finally, what if I said, what is our profit when 0 units are sold? Well, we know that it would be our fixed costs and we would have a negative profit. So if 0 units are sold, we would have a profit of negative $180. In other words, we would have a loss. Remember that on the end here, this 180 in our cost equation represents our fixed costs. We incur those no matter what. So if we don't sell anything, we have a loss of 180. That concludes our lesson on building models from data. So now you should be able to identify the revenue, cost, and profit equations, as well as the key components of each of these, and finally to build each of these equations from a table of data.